All right, so today what we're going to do is we're going to look at another way of organizing the information that you need to be able to do probabilities. So it has nothing to do with the probabilities itself. It's just a way of putting out the information so that you can then read the things that you need to do your probabilities. Okay, so it's just a way of organizing the data. So what we're going to do is talk a little bit about two-way tables and what they look like first. So if you have a two-way table, what it means is that you have different categories of data. So, for example, you can have owning a car or not having a car. Now, I'm going to write it as not car, then I'm going to change it because there's a statistical notation for that. If I have car is having a car, what's not having a car? There we go. Car with an apostrophe, that's car prime. That means not. Now, then we need another category. So let's say we ride our bike. So what's the second one then? Bike with an apostrophe. Bike prime, not having a bike. Right? So, and those are just two made-up categories. It doesn't really matter. But you're going to be comparing two categories. So we could be comparing students and teachers, whatever. It doesn't make any difference. Now, but probably the most important part, and then what's going to happen is you're going to have the numbers for each of those things here. Probably the most important part that many times they do not put on the chart, and you need to, is you need to have totals. Because remember, all probability is based on how likely something is to happen out of some number, right? And so if you don't have the totals, then you're going to be in trouble. And you're going to have totals for the rows. So there'll be a total there. Then you're also going to have totals going up and down. And here in this area is where you have your grand total. That's the total of everything that's happening. And that's important because if you want to know what's the probability that any student has a car and a bike, right? That's everybody. So that's where that grand total is important. And that's the one you're going to use more often than any other total. But I could also be looking at just this column. I could say of the people who have no car, then that means I only want to look at this column, in which case this would be the total that I need to use. And that's a reduced two-way table. That's what we're going to look at next time. Okay? So pay close attention to which number of outcomes that you need. Okay? All right. So we're going to look at some of these, and it's very straightforward, but you need to read carefully because the hardest part of this is determining what is it exactly that I'm measuring and which total do I need to use. Otherwise, these are really well organized. Okay? But it's just like a probability tree again, that you're just looking at ways things are organized. Here we go. So the data below shows items in 3 people's wardrobes. So you see this time they have 3 people. Doesn't matter. It's still a two-way table because if you go down here and across there, those two categories lead to an intersection which represents one number. So for example, Ricardo and the number of pants that he has, Ricardo and pants, it goes two ways until you find out that he has 2 pairs of pants. Okay? A little odd, but anyway. Okay, so here we have shirts, pants, and ties. We have 3 different people. I have no idea how to pronounce that one, so I'm not going to use it. All right, and we're just going to answer questions. What is the probability that a randomly chosen item, so randomly chosen, so is that giving me some restriction? No, that's out of any item we have. A randomly chosen item is a shirt. So if it's randomly chosen, that means I get to choose out of any item that we have. And so that means I'm using the grand total of 31 as my denominator. Does that make sense? And for shirts, there's a total for shirts because it's any shirts. It doesn't matter who it belongs to, right? So I get to ignore all the names and go straight over to the total number of shirts. And the total number of shirts is 16 over 31. Okay? And that's all there is to it. Now, again, you can leave the probability as a fraction as long as you simplify it, if it will. This one won't simplify. Or you can change it into a decimal rounded to what? 4 decimal places, always, for probabilities. Now, they could ask you what percentage of items were shirts. In that case, you just change the decimal into a percent by moving the decimal 2 places and adding the percent symbol. Okay? So again, doesn't change the probability. It just makes it easier for you to read. Let's drop down to the next one. What is the probability the random chosen item was a tie from Terry? So this time, it's still a randomly chosen item, yes? That means the total that I'm going to use is what? 31. Oops, sorry, let me bring the chart back down a little bit. 31. But this time, I want a very specific item. It's a tie from Terry. So going over from ties across to Terry's, and how many ties does Terry have? 5. So 5 out of the 31 items would be Terry's ties. Okay? Very easy, very straightforward. Okay? Now again, that won't reduce, but you could change it into a decimal if you needed to or wanted to. Drop to the bottom. What is the probability that a randomly chosen item was not from Terry? Well, again, it's a randomly chosen item, so which total am I going to use? 31, the total of everything. But this time I want not from Terry, which means I can't use any of these items that Terry had. So, yeah. So that means all of his items and all of his items added together. Yeah? Which would make what? Okay. So just mark off what you don't want and everything else will count. Don't go back to adding all of these because you have nice totals at the bottom there. So use those totals. Okay. Now I can't use any of these totals. Why? Well, they include Terry, right? Okay. So that means I have to go up and down on these to get these totals. Yeah. Because I only want to look at the people's names, the specific people. Everybody but Terry. Okay? Good deal. All right. It doesn't get any harder than that. So there, they did all the probabilities. Oops. Sorry, I didn't do the probability statements. And remember, if you do not do the probability statements, what? Your answer is wrong. You can't even get an achieved. So make sure you're writing those probability statements and be very specific. Now, you can abbreviate. So you didn't have to do, you could do T, but you couldn't do T and TY. Don't know which is which, right? So be very careful when you're abbreviating, okay? Now for him, I could abbreviate his name as E all day long. Why? Nothing else would be abbreviated E, right? But be careful. You can abbreviate, but make sure your abbreviations make sense.
Wait, this the probability statements.
Pardon? Sorry?
That's the probability statement.
Yes, this part with the P of whatever it is you're measuring. Right? It doesn't need to be all caps. They're just really trying to show you that it's got to be this and that. Yeah. Don't get carried away with the caps there. Okay, let's look at another one. So sometimes you're not going to have all of the information and you're going to have to put the information in. So in this case, here they don't even give us a two-way table, so we have to build it first. But they're very easy to build as long as you remember that everything has to add together across and up and down, right? So let's just build this probability. A new drug is being trialed with side effects reported for some of the trials. A placebo or sugar pill was used in some of the trials. The following information is known. Okay? So we'll build our table. And again, it's going to be a little messy here because of where I'm writing, but it's all right. Do not forget your totals columns. It is probably the most important. Okay? It says there were 120 trials recorded in total. So where's that going to go? Down at the bottom. That's how many total out of every trial. Okay? Good. There were 60 placebos administered. Okay? So we need to know there was a placebo, and there was a total of 60 placebos administered. Yeah? So we could put that in. There were 12 trials where the drug was taken, and there were side effects. Okay? So that gives us our other one. So we have a placebo. What's the opposite of that? Well, not placebo, right? Or drug. You could put drug or not placebo. It means the same thing. Right? No big deal. And then we either had side effects or what? or not side effects. Does that make sense? Okay. There were 12 trials where the drug was taken and there were side effects. So that's not placebo, that's the actual drug. And again, you could put not placebo or you could put the drug, doesn't matter. And there were side effects, so that's right here. Right? The intersection of side effects and the drug. Because the drug was taken and we had side effects. So that means that intersection. Okay? There were 5 where the placebo was taken and there were side effects. So side effects is the top one. Placebo is here, so that's 5 and 12. And that's all they give us. But it's enough to find the rest. Because in order to get this total, all I need to do is add my 5 and 12, which gives me 17. Now, here I have a total at the bottom, and I know part of it. So I'm not going to use addition, but what? Subtraction. So 60 minus 5 is going to give me 55. Now I have 2 missing there, so I can't do anything here. So I'll go over here. I know 2 of them. I know the total and I know part, so I'm simply going to use what? Subtraction. And what's 120 minus 17 going to make? 103. Now I know enough to be able to get this. I know the total and a part, so I just take 103 minus 55, which is going to give me what? There you go. Oh, well. Okay. There you go. And now, finally, I can get these two. Add those together. I'm going to get what?
60.
Right. Which I knew that was going to have to be 60. Why? Because you had 60 here and 120. So it doesn't matter the order you do them in. Just make sure you get them all done. Okay? All right? So many times you're going to be given this information in sentences and you're going to have to create the table to be able to work with it. Now, it's simply a matter of answering the questions. So we use the information to construct the two-way table. Hopefully you wrote that down because when I push this button, mine's going to go away. Right? If a person participating in the trial was selected at random, what does that tell you? We're looking at what? Everybody, the grand total, the bottom one in the corner. What is the probability they would experience side effects? So that means any side effects. So I'll just go along for side effects, and that total was what? 17 out of how many total people? 120. Okay? So, very straightforward. So here's our total. So side effects, they did it in different. Does it matter that they put side effects and no side effects at the top and I put it on the side? No. So side effects was 17 out of 120 total people.
Is there any rule about that they expect you to put?
Absolutely no rule. Doesn't matter. Okay? Probability of having side effects and having taken the placebo. So placebo was here. Side effects is here. So how many is that? Out of how many total people? 120. Okay? Now, all of these, well, I'm not going to say most. All of these today should be out of that grand total. And the ones we're going to look at next time, we're going to look at what happens when you can't use the grand total. All right? So that'll be changed these. Now, I'm not guaranteeing that, but I'm going to say they should be. We'll see. All right? So I'm going to give you an assignment to work on. Hold on.